Kia ora koutou, good evening, everyone. Thank you so much for joining us this evening. Thank you, Ben, for being here.
No worries. Thank you for having me.
So everybody, I don't know if they've updated the titles under our faces yet because we've quickly jumped around today because we've had a lot of lives going on. So sorry if that's confusing, but Ben Peters is our candidate for Dunedin. And it's going to be a very interesting race for you down there. Ben, tell everyone who you're running against.
So I'm up against Michael Woodhouse of infamous toilet seat fame currently, and also David Clark, the two main opponents. And I think we all know David Clark and his recent history here in Dunedin. So he's making an effort there to reconnect with people after a bit of a whoopsie, or a couple really.
Just a few.
One. There's a couple in a row there, so pretty interesting race down here. And I guess I'm really just trying to raise the awareness of science and trying to make that kind of front and center at the moment, and really pushing evidence into Parliament is kind of my big focus. And I think that's quite a contrast to at least the behaviour of some of those MPs there.
Totally. So just tell everybody, if they've never met you before, Ben, what do you do?
I am a professional practice fellow at the university, which means I teach. I teach biochemistry. I do some designing of the lab, some of the undergraduate courses, design some of those as well, resource development, that kind of thing. And then in all of my time to make sure that I'm teaching what's true and accurate, I spend the rest of that time researching and reading out papers, making sure I'm kind of aware of the current literature going on in the world. So that's my main job. Ton of student contact, which at the moment is slightly more. It was great before we had COVID in the country. Now that it's in there, students are a bit renowned for mingling, should I say? And so I mean, like today in our labs, we, myself and all the demonstrators, we're all masking up just to make sure that we're trying to be as responsible as we can and showing a bit of leadership there and being responsible while being around a lot of people. So. Yeah, that's my deal. I spend as much time as I can reading science, and then occasionally I get an opportunity to share it, and that's hopefully what I'm here to do tonight.
That's awesome. So, Ben, you are a real life scientist, which is perfect because we've got a lot of questions in the lead up to tonight, and that I'm going to start with, and then everybody who's watching, if you also have any other questions, maybe it's a myth that your friends or uncles or aunties have been sharing on Facebook and you're just not quite sure about them, just chuck them in the comments, and Kane and the team will feed them through to Ben so he can answer them for you this evening. So Ben, I'm just going to start with one of the bigger ones. So COVID's been around for a while now, and some leaders in some places who won't be named have been still talking about this miracle drug. And so if there's this great miracle drug out there, the hydroxychloroquine, or the even ivermectin, if they're just this great miracle drugs, why aren't we all using them?
Great question. So both of these drugs have had at least one science paper come out that showed really promising results, right? Which was enough to kind of get the ball rolling. And currently we're all really keen to see something work. And so it's very easy to jump on that and go, wow, that's amazing. The ivermectin one, that was a paper that they added the ivermectin into cells. So you can, instead of putting it into a person or an animal, you grow cells in a plate, the human cells, and then you can add in drugs to it, and then you can add in the COVID-19 virus, and you can see if those drugs stop the infection, or you start off with the virus and then you add the drugs after, and you see if it keeps replicating. And that was the case with the ivermectin. So they did a study like that, and they showed that it reduced the amount of COVID-19 in those cells 5,000%, which is huge, right? Or 5,000-fold, sorry. So it's this huge reduction in the amount of viral particles that were there, and people got really excited about it. But then when we actually looked into a little bit more, and that paper is it's only in cells, so it's not in people, which is a huge difference because many things look promising in a petri dish that don't actually eventuate to being effective medicines. And particularly with that one, the concentrations that we used were really, really high. Right, ivermectin is approved for use for various illnesses currently, particularly head lice and things like that. Or sorry, lice. So it's a common drug. It's very cheap, but the doses used in the petri dish experiment, or the in vitro experiment, as we would call it, that used way higher doses than anything that has currently been used, and is actually potentially unable to reach that higher concentration in a person, just because of the pharmacokinetics, so the actual rate limiting steps of getting the drug into your cells. So
do you mean with that? So do you mean then, if I just translate that, so with the ivermectin trial, the dose level would never be able to be used in a human because it would exceed the recommended dose level?
Currently, yeah. So you'd have to do some extra, not even just exceeds the recommended level, but it's questionable as to whether you could actually achieve that level in a person, regardless of how much you gave them. So it was really, really high. But regardless, the thought behind, or at least the conspiracy behind it, is that because it was cheap, governments weren't interested in it because then there's no way to make money, right? Which, to that point, I would rebut that any government that comes out with the effective treatment is going to be hailed as the hero of the world, and stands to gain an awful lot internationally in terms of being able to be the one that showed that they found the treatment. So there's more money to be found, even though all those countries could produce it themselves and it's very cheap and widely available. It would still be more beneficial for those for whoever found it to announce that, rather than suddenly try and bury it. But regardless, this drug actually has had more funding assigned to it, and so they are still going to look into it and to see if it goes anywhere. The same with hydroxychloroquine, where there was an early study where they showed some promise of it being effective. That particular study, again, had a lot of issues with it when you looked into it. People who died while on the study just got taken out of the study rather than included in their statistics, which is a bit grim, considering that you actually need to, the claim was that it was curing people a lot faster, but if you're taking away all the people that died, then that's really not good. And then some more things came out that paper was really not great. Since then, some more research has been done, and there was actually a paper which showed that there was adverse side effects to taking hydroxychloroquine, a massive cohort, and unfortunately that one was actually also had issues with the data. So these problems with science papers aren't always on one side or the other, and it's really important that we call them out on either side whenever they're coming out, either for a drug or against. But at the heart of all of these is just this idea that cheap drugs, we won't investigate them. It's all about making sure we get a vaccine, because once we've got a vaccine, we can inject people and then we can control people and all of that kind of rabbit trail. And to that, I think we just need to push back quite strongly that actually there is so much to gain, even by finding a cheap drug that will be effective, that it just, the game theory doesn't work in terms of holding out until you've got specifically a vaccine. Because vaccines will still be used, right? Because you don't actually want to just have treatments, because just having treatments will still leave people with some permanent damage. The COVID-19 isn't just about dying or getting sick and getting better. There's some evidence at the moment, some more and more evidence is coming forward that being infected is having a long-term impact on people's health, and that's really quite concerning. So trying to just let it move through the population slowly or something is actually going to be crippling people quite long term. Exactly those statistics and things like that aren't really fully fleshed out, because we're still in the middle of that pandemic, and it hasn't been that long to see how long term those effects are, but that is definitely a concern.
So what can people say to their family member who are saying that we should just let it run through the population and it's just like the flu anyway, so why are we even reacting so strongly to something that is just the flu?
Sure. Well, even if it was, right? So, I mean, clearly it's not. But even if it was, the reason we're not as concerned about the flu is because we have an effective vaccine and we have enough treatment to give people in at-risk groups, right? So we have antivirals against the flu that we can use, that if you present in hospital and you're a bit older and you have some other issues underlying it, the hospital will treat you with drugs that will help you get over the flu. We don't have those with COVID-19, or SARS-CoV-2 is the name of the virus there. So even if it was just like the flu, it's just like the flu back when we didn't have a treatment for it and back when we didn't have a vaccine. And what that means in terms of it just moving through the population, well, that's really bad. Just the flu is actually horrendous. And so we do want to be very, very careful, even if it was just as bad as the flu, but it is in fact worse than the flu, and we don't have those treatments. And so that's why we're taking it so seriously.
And the ask you about was, let's talk about vaccines and herd immunity, because we hear a lot of conversation around that. Yeah. So I guess the first part, kind of touching on from what you just said, if we let it just go through the population, even though you've just explained why that would be a bad thing, but even if we just let it go through the population, would that mean that we would naturally build up a herd immunity?
Not necessarily. So part of the other issue is that we don't actually know how long an immunity to this would last. We don't know if, and the other half is that actually to get herd immunity, you need an awful lot of people who have been exposed to it, and it can be really, really damaging, and would cripple the workforce, right? Because even if you say, oh, it'll just move through the workforce and we'll just keep going, that means not people going out and working, that's people home sick instead of people home quarantining. So the flip side of this is actually not going out and then everybody gets it and then keeps going or whatnot. It's everybody goes out and then they get infected and then they have to take time off work because they're half dying from a COVID-19. Even if they can recover, there's still going to be long periods of time with massive portions of our population at home regardless, because you simply cannot work in those conditions when you're suffering from COVID-19. It really, really does take a huge toll on the body, and we're seeing that with young people and old. It's just absurd, and I think, if you have 100,000 people in the country being sick at any one time, then major issues are going to happen. At least with a lockdown or some kind of quarantine type thing, what you can do is you can keep your essential services working, right? You can keep all your essential workers going to work, and they're healthy so they can. If all of our essential workers get sick, then, hey, that's a whole lot harder to manage getting food to everybody. It's a whole lot harder to keep all our power plants running, all of our internet infrastructure running. So actually, it's a lot more chaotic, it's a lot more random, and it's a lot more disruptive than actually staying home in the first place. And so I think what we're doing is really good.
That's such a good point, Ben, because that's the part of the story that I don't think we talk about at all, or if we do, it's hardly at all, right? So what you've just explained is that if we just let it go rampant, it's not just the concerns around the death rate, it's not just the concerns around the side effects, it's the fact that at any given time, a huge proportion of the population could be off on sick leave, meaning a huge parts of our economy wouldn't be able to keep running anyway because they would be sick.
Yeah, absolutely. And I mean, I think we were quite fortunate when we did our lockdown. We did it really well. New Zealanders absolutely fantastic. Like, I just love how much we all came together. I go out for walks, and I mean, I had to avoid all the playgrounds so my kids didn't get mad at the play equipment that they couldn't play on. But people would say hi, and would all have this weird kind of 3 meter away chat. And things like that. And it was actually quite warming. And I'm really proud of our country and how we have managed to pull together through this. And at the moment, I know, down south, we may not have always super fond likeness of Aucklanders, although I have lived in Auckland for a while, so I guess I can't account anyway. But like right now, Auckland's doing it tough. And we want to say, actually, Auckland, you're all right. We won't succeed from you just yet. We'll keep sending you power.
Thanks.
But like it's about that pulling together, and so I think that's actually really good.
Yeah, I think you're right. And I think we will have that attitude again. And I'm really hopeful that we will stay united and have that attitude again. I mean, I've even noticed just the few times I've been out wearing my mask, and I said this on the live earlier tonight, if anyone's watched both, but you have to squint so much when you're wearing your mask so everybody knows that you're smiling.
You got to get your Paramount smiles on.
Oh, I need to be practicing. Oh, you've got a good one. I need to be practicing that apparently. But
Yeah.
it's good. And even though I felt like no one can really see me because you're so covered, but people have still been saying hi and they get it. And at the end of the day, the more people that kind of cover up and add that extra layer of protection, the better, right? Yep. And that was actually something that is a good segue, because actually this is something I wanted to ask you about, Ben, because I know that mask wearing is a particular area where the information and advice has changed. Can you tell us a little bit about that?
Sure. So I think early on, I mean, there's a couple things kind of going on here, and part of it is how effective are masks specifically at stopping viral particles escaping, right? So how much gets to the other side. And early evidence shows that unless you were using really high quality masks and unless you were wearing them perfectly, like I would fail. I've got a beard on. I contemplated shaving it actually. But unless you're getting that really good seal and you're stopping all of the droplets, then you could still have contagion going. And if you were then touching your mask all the time and then touching other things, then you would actually still be contributing to the spread. But then they did more kind of testing and more modeling and looking at actually in the bigger picture, even if a lot of the viral particles are getting through, how far are they going? How far is it actually spreading when you breathe, when you talk? And what they found there was that actually, if you have just a reasonably good tight-knit weave in front of you, then you can actually you'll still get some stuff going through, but it's much, much less. And that because it's much less, then there's much less virus actually going on to people around you, and most of it's going to be falling onto the ground instead. And then when you pair it with good hand washing, and especially when you pair it with like a high level of compliance of people being good about distancing and that hand washing, then actually it does become really effective. But the other half is that compliance question. So if the government mandates and people have a big protest, then that has had an opposite effect of what would have been beneficial, right? So there is always this level of what can we actually get people to do at the end of the day. And I think New Zealanders are wonderful in that we go, yeah, all right, we see what's sensible, we'll do it. In other countries, it hasn't been the case, and so it's been much harder to implement even stuff on paper that looks really good and effective, like mask wearing or staying home or all of that stuff. When the government's tried to say to do that in other countries, that hasn't happened. You've had these mass protests and things like that, and then you've had potentially resulting outbreaks from there. Although I wouldn't want to tie those two immediately together because I haven't looked specifically at that, but you need that level of people being willing to. And with New Zealand, with our lockdown, there wasn't really a point in mandating mask wearing while we were also doing a really, really strict lockdown, because you'd already cut out pretty much all of your contacts, and there was still a fair amount of mask wearing at supermarkets and whatnot, which is really good. But because we had a really heavy lockdown, it wasn't as necessary, and then you don't want to overburden people too much or the compliance drops, and would rather have an effective lockdown than a half effective lockdown and a half effective mask wearing. And so you kind of end up in this position of not just what's the best approach in terms of what does the evidence suggest is the most effective, but also how effective are people at actually implementing that. And so I think that's where we're at now, where we really don't want to do a hard lockdown again. And so that's why we're moving more towards let's start wearing masks, because that's a whole lot better than a big lockdown. I taught for 6 hours today with the mask on. It was pretty good. I did get to show off my smizing eyes. The jokes were a little hard to land. I tried to be a bit sarcastic with students, and they would think I was way more serious because I was wearing
they couldn't tell you a joke.
They couldn't see my smile underneath as much. But I mean, we had a couple of nifty workarounds. Like if you're wearing glasses and it fogs up, if you put a little bit of just tape on top of the mask at the top there, it makes a nice seal, and then most of the air escapes out the side or underneath, so that stops your glasses fogging up as much, which is really good. And I actually had one that looked over, and so I looked over my glasses so it wasn't pushing on my ears as much either, and that made it more comfortable as well. But it was still really possible to interact nicely with students, and some of our students were wearing masks as well, which I was really pleased to see. So, I think it's, for us at the moment, yes, that evidence has moved forward. And in fact, the last paper I had a look at was showing that mask wearing can even give you a small level of immunity, because if you come in contact with a smaller dose of the virus, there's evidence that you're going to get less sick. which means that you might gain some antibodies and have a much less severe illness simply by wearing a mask. It may not 100% stop you from getting COVID at all, but it can actually mean that you come into contact with a very small dose, which effectively acts like a vaccine. Not exactly, but in effect, you get a small dose, a milder illness, and then you can recover quicker. So the dose of virus that you receive seem to play a part, and masks seem to play a part in reducing that.
Wow, that's crazy. That's awesome. And that actually brings me back. I know you slightly touched on vaccines earlier, but before we go to if anyone has questions, I want to ask you. So countries all around the world are working towards a vaccine. And to have herd immunity through vaccines, what level of uptake would we need to have confidence that we could just go about our normal lives, and when we have these flare-ups and flare-downs, we wouldn't need to just push pause on everything?
Yeah, so that's going to be really high. That's kind of like 90-odd%. Right, when we look at things like measles, when vaccine rates drop down to 80% or worse, that you start seeing those outbreaks happen. And I mean, I couldn't give you a very specific number. It is slightly outside my field there in terms of putting a very specific number, but you need really high uptake to do that. I don't think that will be the strategy, because that requires pretty much vaccinating the entire world, which is 6 billion odd vaccine doses. Vaccines aren't easy to grow, but it depends on the vaccine. Actually, some of them are much more able to be scaled up in terms of manufacturing, but they're slightly less proven as a technology. So there's a couple leading vaccines there. The interesting ones that can be scaled up really quickly are the ones where they make the DNA or the RNA of the virus, not of the whole virus, but of a recognizable piece of it, and they package it up and then they use that. And so then in your own cells, you'll make that small piece of the virus, not enough that it can replicate or anything, but in you, it will make something recognizable that goes, oh, that looks like the virus, and therefore you can attack it and make antibodies to it. That virus, that vaccine approach can be scaled up really quickly. Other approaches which use a known virus and then modify it to look like COVID-19, SARS-CoV-2, that's a little slower because you have to make lots and lots of that viral particle. But we are seeing international pharmaceuticals preemptively making as much vaccine as they can on their kind of pretty much playing bets. I think this is going to be the winner. So, and we have to start production now in order to be able to do a good rollout. Probably what you'll see more in New Zealand is something like ring fencing. So vaccinating people that are in high risk areas. So vaccinating all our border staff, vaccinating all our rest home workers or people that interact with high risk. And so what that will do is effectively allow us to be a little bit more flexible and really reduce the chance of an outbreak while not being 100% just go about your day, because we also need to have a look at that international context where New Zealand is going to be kind of low on the list of people to get a vaccine just because we've handled it so well in every other aspect. But we will absolutely hopefully be able to get some vaccine to do that kind of extra protection around the borders and around the at-risk groups.
And what can you say to people who are really scared that the vaccine that we're going to eventually have is going to have been rushed through? So will it have the same level of safety as all our other vaccines that have gone through rigorous testing? What can you say as far as the processes go around developing it and upscaling it?
So there are things that have been rushed, but there are things that haven't. So the things that have not been rushed are actually taking the time to do those trials, taking those times to test the safety and to test the efficacy. The things that have been rushed has been the development of it. So usually you can take your time to develop something. There's not a huge market for it and there's not a huge drive for one. And so there'll be a research group or two kind of just puttering away, not puttering, that genuinely working hard at getting a vaccine done. With something like the COVID-19 vaccine, something like the Oxford group, their strategy, the reason they could be so fast at what they did was they were already working on a vaccine for MERS, which is a Middle Eastern respiratory syndrome, which is very closely related to SARS-CoV-2. So it's kind of close-ish, has a way higher death rate. It's about 30% death rate. And so they were working on a vaccine for that. when SARS-CoV-2 emerged, they very quickly redirected that research that was already in place. So they had already done a huge amount of work getting their systems up and running and ready to go. And then when this came around, they very quickly pivoted, and it's still going to go through all those same safety checks. So the safety checks aren't being rushed unless you're Russia. But the rest of the world really is taking their time, making sure that these vaccines are hitting all of the trademarks, so all of the milestones that they need to in order to be safe and effective. Because there's always the chance that if you don't do those steps properly, you can actually end up with a worse response to the virus or something like that. So there is great care that's being taken, and also because it's such an international effort, there's an awful lot of I guess there's a lot of different players in there that are scrutinizing it, that are making sure that whatever happens is actually going to be true and accurate. And so in the case of Russia, I guess I've brought it up, but there's they're going ahead with a vaccine that hasn't been fully tested. Obviously, we're not going to be importing that one. It is a low chance because it did pass phase 1 and 2. So phase 1 trials is largely about safety. It's a very small group of people, and they just test to make sure that nothing goes horribly wrong. Really closely monitored. No measure of efficacy. Level 2 is a wider one where they look a little bit at safety again and at dosages, and then after level 3 they roll it out to see if it's effective at actually raising the antibodies that they need. And you get some of that data in phase 1 and 2 as well.
So Russia's rolling theirs out without knowing it's effective.
Yeah, well, they've got limited data from phase 2, I think, that on whether or not it will be effective, and they say that they're doing phase 3s currently, but at the same time as giving it out. I don't want to spread any misinformation there in terms of I haven't spent a lot of time looking into what Russia specifically is rolling out versus what they're just doing in terms of phase 3s. In terms of the design of the Russian approach, it's actually quite similar to the Oxford group, so there's a reasonable chance that it'll work. But it's a case of going, and the international community going, no, actually, it's important to do everything slow and steady. Even in these rushed circumstances, we are actually taking our time really importantly there. So I guess that's just an example of when someone does try and make a shortcut, they very quickly get called out, and it's very widely known and publicized. So you can be reassured that in all the cases that you're not hearing anything about things being skipped ahead, that it's because it's not. Scientists don't do a great job about banging drums and making noise about the work they're doing. So I guess that's part of why we're doing this live, right? So we can share some of that information.
Exactly.
So yeah, the vaccines are absolutely proceeding with great caution and making sure that we are actually meeting all those safety milestones along the way.
And that feeds into one last question I was going to ask you before we bring in other questions from people watching. How can the public have confidence in when someone says it is scientific research or scientifically proven? Because a lot of people out there who maybe passed School C science, maybe didn't, have watched a YouTube video, and the YouTube video has told them COVID is a hoax and not to trust scientists. So why should we trust this YouTube person who's never passed science over scientists who have studied at universities and studied afterwards, and it's their career? How can we give those people confidence?
Make friends with scientists. We're not a very social group, but at the end of the day, we trust information that's close to us, right? So we rely on people that are near to us to inform our views and to bounce ideas off. Scientists are actually pretty friendly if you send them emails, if you reach out to them, and they often do respond. So I guess I would actually encourage people to reach out. If someone's put forward a paper or there's an article, ask for a source, right? So the number one is actually just check if it's actually published in a journal. The other thing you can do is you can check how reputable that journal is, and you can also check what people have said about that journal. And there are a couple of ways of doing that. You can just Google the journal and then add impact factor on the end. An impact factor kind of is a ranking of journals. It's not perfect, but it will give you an idea. So any journal that's kind of under an impact factor of 1 is probably trash. Like, I'm not saying it's always trash, but it's very unlikely to actually be that reputable. It means that the peer review is very skint. Not always, but kind of broadly speaking. 1s, 2s are okay, but they're quite low, so quite a niche field. In the case of anything COVID related, the amount of citations that are coming out, the amount of people that are reading and posting on things is really, really rapid and really huge. So you're going to see an awful lot of people just citing those. You expect quite a high impact factor. Kind of anywhere from about a 3 to a 5 or is probably somewhat okay. Fairly good. You should be, they'll probably put in some good effort there, and it takes a bit of effort to get into those journals. If you're going above a 5 and you're up into your 10s in a specific area, that's great. And then you have your absolute outstanding one. So if it's published in Nature, if it's published in Science, if it's published in Cell, they're the kind of the gold standard journals that everybody dreams of getting into, and I have not. So that's kind of number one, is just where is it published? Because there's absolutely a range of scientific articles, but there's a huge range in terms of what's actually published and accurate. And at the moment, an awful lot of papers are getting published in what they call bioarchive, which is a place where you can put up papers before they've been peer reviewed. Really great for disseminating knowledge quickly amongst scientists. Also problematic in terms of making sure things are actually peer reviewed and checking any issues that come up. So that's the other thing I'd say is check where, absolutely check where it is, rather than just is it a science journal. And the other thing is you can look at who's cited it. What are the other scientists saying about this particular paper? And the way I would do that, I might be cheeky, and I might try and share my screen here. I'll just hit up Google Scholar, because there's always you get a little bug for teaching at some point, and you're like, yeah, let's go. So check up Google Scholar here. Give me 2 seconds. Where's my actual Skype chat? Here we go. I can go share screen. This one here. Start sharing.
I'm getting like a proper class.
Absolutely.
Yes, I can see that. Awesome.
Okay, you can see that. That's going.
Hopefully people at home can see that.
We can look up anything we want. I've already got filled in the ivermectin, so that's one of those drugs that I was talking about. We can just enter and see what we find. Right, there's a huge number of papers that are coming up, so I've got 80,000. We don't really care about anything other than this year, so we'll just narrow it down to 2020. This is one that I've clicked on before, and this is kind of that early paper that I talked about, which showed the huge efficacy. What we can do is we can click on the little cited by. Right, 410 people have cited that paper, and then you get a huge number of people that have at some point referenced that paper. And if you really want to go into it, and this is what I spend far too much of my time doing, you then read what other scientists are saying about it. And these are all the other scientists that have referenced that paper and that are mentioning it. This one here is really interesting. So a review of SARS-CoV-2 and the ongoing clinical trials. So that will give you an idea of what trials are going on, and that will list the different medications that are currently being trialed around the world. So if you're like, is anybody trying X drug or Y drug? Well, there's a paper that will have a look at it. This one down here, the current status. Oh yeah, sorry, I'll zoom in a wee bit so people can see this a bit easier. How's this?
Nice.
One down here, current status of potential therapeutic candidates for the COVID-19. That's a great one to have a look at and just go, let's actually see what's going on there. Gives you, when you're reading a science paper, there's often some highlights or some and a little abstract, which will just kind of give you a really quick rundown of what's going on here. So as of April, so it's a little bit out of date, but we've had a huge amount of individuals that have been infected, and there's a number of therapies that we're looking at. And then this one will probably break them down. I won't go through all of it because it'll get fairly lengthy, but it gives you a good idea, of where these different drugs are targeting and what's going on. So if you're really keen, if you want to do that kind of research, I mean, you need access as well, which is the other problem that it's actually, sometimes you need to email scientists. Scientists are often allowed to, I'll just stop my screen share there. They're not always allowed to publish full papers elsewhere, but they are able to actually send out copies of the paper. So that's another thing where it's totally fine to email a scientist, be like, hey, I saw this paper, I was really interested, can you send me a copy? And often they're allowed to do that under their publishing rights. So if you want to engage, there's a way to go engage. So where is it published? Check if that journal is reputable, and then have a look in and see who's citing it and what are they saying about it. Because often some of those, the more dubious ones, they've sorry, what am I saying there? The more dubious ones will have lots of citations pointing out the flaws in that paper. So that's a really good way of just checking that. You can also just search for news sources. Various news agencies are higher or lower in repute. I know in New Zealand there's a little bit of a range there, but internationally there's a huge range in terms of what is good or what is not. So I guess that would be my very long-winded answer in terms of what do you do when you get presented with something you don't know. Ask a scientist if you can, or investigate it if you know. I'm trying to reach out to or respond to as many people coming up with their whatever they're asking or saying. And I mean, I walked through some of that evidence on an ivermectin drug with a person very recently, actually, because they weren't sure, and it seemed weird that a drug that showed such promise wasn't getting funding, but it took a little bit of digging to find out that actually it was getting some ongoing funding, and it'll be interesting to see where that goes.
So basically the science community calls each other out, right? And so
the time.
you're a competitive bunch.
Yeah.
So if people had a great miracle cure, then all the scientists would get on board to say, hey, look, we've tested it as well, and it is this great miracle cure. And if it is horse trite, they're going to call that out too.
Yep. Twitter is surprisingly good at for scientists communicating. There's a number of scientists that, and think I've learned information from scientists on Twitter, sharing their beef with papers and things like that. So maybe I'll try and share out some of the scientists that I'm very keen on. But there's there's a lot of good people out there trying to share information and that are trying to critique stuff as it comes out. So really finding a reliable news sources and using those are absolutely key. And again, scientists are very happy to chat most of the time.
So with that, being a scientist yourself, happy to chat. Should we get some questions going, Kane?
Sure.
Because I can see somebody's already asked one. Is that the first one coming through, Kane? Okay, cool. Yeah, I can see that. Awesome. So, okay, Ben, what do you say to people who don't trust politicians or don't trust scientists because they apparently can't agree on anything?
So, I mean, again, there's nothing you can say that's a magic combination of words that will make them believe you, right? And that's what I said at the start about befriending a scientist, is that it kind of, you need to have some credibility with the person first before you're then able to speak about the things that they are uncomfortable with. So there's some people close to me that I have quite very different views on, but because we have a close personal connection, really productive conversation around difficult topics, we're able to bash our heads a lot. If I do that to people on the street, they're going to hate it because I'm just coming in screaming that I'm right and they're wrong. So it really is actually, we need to do a better job of fostering relationships first so that we can then speak in with the scientific knowledge that we have or with politicians. So it's very hard and it's very difficult to talk to your friends and families when there are those different views. But as friends or as family members, you actually sometimes have the most ability to speak in rather than strangers on the street. I think politicians haven't done themselves a great favor of late in terms of putting honesty and truth above gaining power. So I absolutely understand why people don't trust politicians. And I think, the comments of Jerry Brownlee made me very furious. I'll refrain from saying stronger words, but sowing disinformation and sowing those seeds of doubt at a really crucial time in New Zealand's history, I think is just so thoroughly irresponsible. So for people who don't trust politicians, we'll vote them out and get fresh ones in. Just keep the churn going.
Totally.
And if you don't trust scientists, I think just reach out and start asking them questions. People are quite happy to respond. Scientists often don't agree, but when scientists aren't agreeing, it's not the same as saying the other person is necessarily wrong. So scientists will be very fierce about what's right or accurate, but what they're debating about is often not, are my hands upright, but are my hands exactly at 0 degrees, or are they at 1 or are they at 2 degrees, And so they'll start screaming, saying, no, absolutely, those hands are not upright, because when you say upright, you're meaning 0 degrees, and there is clearly a bit of tilt there, Ben, therefore I'm not going to endorse that your hands are upright. It doesn't mean that they're down, right? Like that's a huge difference. All the scientists are often debating is like, well, I'm not comfortable saying that that's upright because the way I define that is very narrowly, etc. So scientists disagreeing, we kind of have our own language and lingo when we're saying that. We say, correlation is not causation. It also doesn't mean that it's not, but it just means that we.
And you see why people get so bamboozled by this specificity and this nitpicking, which is the profession, and we value it, and we're so lucky that scientists are interested in that absolute minuscule finite detail. But the problem with that is that it does get mistranslated, because we deal with this situation where there are still a lot of people out there who think that the science community don't agree about vaccines. There are still people out there who don't think that scientists agree on climate change because they've heard one scientist disagrees, or they've heard one scientist disagrees with vaccines. And so it creates this idea that it's 50-50, even if it's 99% over here and 1 over there.
Yeah, and even there, the here and there is often is probably the more misconstrued thing. So it's not often that even in the scientific community that may have doubts about certain aspects of climate change, it is only about certain aspects, right? So there's an awful lot of people that are enormously congruent, but again are just taking that slight deviation off, that's still pulling the same way, still forming the same team. But when you ask them on a yes/no question or on a some kind of questionnaire that's very narrowly construed, that it will present their view as being very incongruent or very different from the rest of the science. If you sat down for half an hour, you'd find out they're actually enormous agreement there. It's just when you try and box them into a yes or no, they go, it's more nuanced than that. We can't just say yes or no. And it's actually, in one of the debates I did, they asked for yes/no questions, and it was just killing me inside. Cause I'm like, this is so nuanced and complex. You can't just put me into a yes/no box. And partly I blame journalists on that. That's not scientists necessarily anymore. That's the journos not being able to give scientists the light of day to actually share their nuanced views, but also on scientists as well by always being way too complex and rambling on like I am now.
And with that, we'll keep going. So the next question is from, is this the next one, Kane? Yeah. Rachel, how can they make a vaccine for a virus that keeps mutating?
Great question. So what we know so far about the SARS-CoV-2 virus is that the mutations it's picking up are slow. And so that is meaning that, it's very useful for us to be able to track it and trace that virus. So you've heard the Prime Minister today speak about the genome sequencing that they're doing that allows us to figure out whether it was in New Zealand already or if it's come from overseas. That rate of mutation is quite low. And also where the mutations are matters an awful lot. I'm going to do a quick Google just to double check how big the SARS-CoV-2 genome is.
Tell us, what is a genome?
Oh yeah, so a genome is just the entirety of the all the genetic information in it. 2 seconds there. So everything that it needs to be what it is encoded in the genome. And for SARS-CoV-2, I'm not pulling up immediate answers and I won't delay anymore, but I think it's in the round about the tens of thousands of bases or something. So it's a fairly small genome, but we're still only getting about 1 or 2 changes out of, 10,000, 20,000, I think. For reference, humans have about 3 billion bases, and we pick up some fairly big changes fairly frequently. So viruses are quite small, quite compact. Yes, it is mutating, but at quite a slow rate. Almost all of those mutations are deleterious to it, so make it worse at infecting. But most of the mutations are either going to do nothing, because there's redundancy in the code. So there are multiple ways to spell the same words in a virus, and so you can get spelling errors and still make sense of it. But other than that, you also the main things that we're targeting in the vaccines, to actually get to the question eventually, that is not changing much at all. And so as long as that doesn't have huge changes, we'll still be able to target it and we'll still be able to have effective vaccines against it. It's also part of why it's great to have multiple vaccine strategies that are targeting different parts of the virus so that if one does change, we can then adapt to it. With something like the influenza vaccine that we have, that changes a lot more each year, and so the strategy we employ there is to look over in the northern hemisphere what strain is currently dominant, get the vaccine for that over here, so when winter comes in the south, we're pre-prepared for that wave of influenza that comes, and then the south looks at what's happening here. Sorry, the north looks at what's happening here, and so on and so forth. So you can prepare for these things if it is mutations that are happening. So far with SARS-CoV-2, we know that that's happening quite slowly, and so the vaccines we're developing are most likely going to still be effective.
Cool. That relates. Yeah, Kane? Oh, okay. Ben, can we do a quick fire of the myths that we went through earlier in case some people have just jumped on midway through?
All right,
okay, so really quickly. Okay, really quickly. Is there a miracle drug that we're just being deprived of?
No. If there was, it would be massively beneficial to the country that found it, and therefore they would release it and not hold it back.
Okay. Is COVID just like the flu and we're just overreacting?
No, it's much worse, and even if it was just like the flu, that would be really bad because it would be like the flu before we had drugs, before we had vaccines against it, and that would kill way more people. So no, it is worse than the flu.
And are we only worried about the death rate, or is it something else?
No, there's also the long-lasting impacts of people who have been infected that aren't recovering very well at all. And we also have to worry about huge portions of our population becoming sick and physically unable to work, which could disrupt our supply chains. They could disrupt us getting our medicines and our food sorted. So that's why it's better to have a lockdown than to have rampant sickness that would make all of that way less stable.
And will New Zealand just make us have a vaccine that hasn't even been tested yet?
Not at all. New Zealand will be very cautious, in particular because we've already done a great job at keeping it out. Even the latest outbreak is a singular case, as from all the evidence that we have so far, is a singular outbreak point, and so we're managing that quite well. And so New Zealand has a low need to rush on vaccines, but we do absolutely need to make sure that we take all the safety precautions.
Cool. Kane, let me know if we've missed any key little myths that we covered earlier. Okay, cool. Otherwise, let's keep going.
Awesome.
Brad, do we know for sure when COVID-19 mutated into existence? If not, how do we know when it came through New Zealand?
Awesome. So this was really interesting to watch. Around the early stages when we started talking about SARS-CoV-2. This was start of the year, early January. The international community was really picking up on it. I spent a lot of time watching. There was a couple phylogenetics blogs. So this is a place where researchers were posting the genetic distance trees between SARS-CoV-2 and related viruses as they became available, and we're really digging into that. So by sequencing the genome, we can figure out where its nearest ancestors are. We can also figure out, based on its mutation rate, kind of how long it took to come into existence. And we can also do some back tracing to see actually previous people, were they sick, or was it all part of, has it been around for a long time or whatnot? And so we are able to go back a wee bit and check people who were sick, if they were actually sick with COVID-19 or not. And so we were able to be fairly certain of the date in which it did the jump from animal to people. And that was around about November of last year. It was a little bit before the wet market. The wet market seems to be the big outbreak event. That is where it started to go a lot wider. It then got picked up and kind of spread throughout. And by looking back in other countries, we're able to see, and especially with modelling, they were kind of able to infer probably when the first people came through. In a lot of cases, it was earlier than expected. New Zealand was quite fortunate being at the end of the world, where we actually had a fair bit of delay before it got here. And so we can tell relatively certainly when it did turn up in New Zealand. For a lot of the clusters, we're able to track it back to the point at which it actually landed on a plane. And so, especially with the recent data that was looked at, so they looked at about 50% of all the viruses that have been that turned up in New Zealand. So 50% of the cases in New Zealand had their genome sequenced. They did an analysis of that, and they were able to find out all the different infection points, again, because you have that slow mutation, so you can tell the difference between one from America versus one from China versus one from wherever else, Iran or Korea. And so we were able to tell where New Zealand's infections came from and roughly when New Zealand's infections came, based on kind of that molecular clock of how often we expect it to do its mutations.
It honestly blows my mind that science can do that. It's pretty incredible. And for anyone watching, actually, I have to do a plug here for Paddy Gower, because he did this incredible piece on exactly what you're talking about. I don't know if you caught it, Ben, but I think it might have been last night perhaps, but it's on New Hub's Instagram anyway. And they went through and explained how you can track the source, the country source of all of our infections in New Zealand and where they've come from, and it's fully mapped it out, and it's really interesting. And it's so great to see journalism actually get into the nitty-gritty of the science on this. So that's exactly the point that you're just saying, Ben. So anybody at home, I totally recommend you go have a wee look, because it illustrates the point really well.
Yeah, there's been some amazing science communicators doing an awesome job trying to communicate the science as much as possible. The only reason I'm up here doing this is just because I think I have a slightly different audience who may not have heard it yet, or who want to get a bit more, someone with a bit more of a connection to them, so they can get a bit realer. I'm not trying to say that I'm better than or have different information to those other science communicators. This is just another voice joining the chorus.
Nice. And we're lucky to have you, Ben. Okay, let's keep going with questions. Okay, cool. What's your take on another level 4 lockdown and what impact it will have on the economy and people's way of life?
Cool. I think a level 4 lockdown is going to be unlikely. For New Zealand, it would be, I think it would be fair to say a level 4 lockdown would be a failure of our systems that we currently have in place, because it would mean that we would have had to have had multiple breaches of our border security. We would have had to have multiple clustering outbreaks, and in order to reach the level where we need to go to, where we need to go to level 4. And in terms of then what it has, the impact on the economy, obviously that'll be absolutely devastating. And so we really want to avoid that as much as we can. I think that's why it's been quite sensible that we've been very cautious about who we are letting into the country at the moment, making sure they're going through quarantine. I think there are some interesting questions around how we do quarantine, what's the most effective way there. I saw a really interesting piece on, I think it was on Stuff, asking about some air bases, whether we actually build facilities outside Auckland to host most people, because it does seem a little bit silly to have most of our sick people quarantined in the middle of our economic centre. And it may make a bit more sense to have them a wee bit further away, so when we need to do these extra lockdowns, it's not hitting the place where most of our business is done. So I think there are really good conversations we can have around that. If we had a competent opposition in Parliament at the moment, that might be happening, but I don't see them raising anything sensible, which is really tragic. I think good governments are made stronger by strong opposition, and it's clear that we're lacking some strong opposition in Parliament at the moment. So I would hope that we can avoid a level 4 lockdown. And really, it would take multiple failures on our systems that we currently have in place in order to reach a level 4 lockdown. But again, it's better to have a level 4 lockdown than to have widespread sicknesses, because you can have a much more planned and prepared way of making sure we still manage our supply chains, of making sure that the core parts of the economy can keep turning over.
Nice. Kane, should we just do one more? Because I've just seen the time. Maybe we'll do 2 more then. Sorry.
Yeah, we can do 2 more.
Okay, 2 more. Actually, before Kane pulls up the next one fun myth that we may as well just touch on, because, it's Friday night and for lols.
Right.
Did 5G create COVID? And if not, why not?
Fantastic. No, 5G is actually going to reduce the amount of radiation that you receive compared to previous generations.
What?
Because I know, and all the chats like, it's going to be more and all intense, and it is slightly different wavelengths. to understand it a wee bit, right, 5G is a wireless technology that runs on the electromagnetic spectrum, which has also got visible light on it, right? And it's a bigger wavelength than visible light, so it's up in the further reds, not smaller like UV. It's a very big wavelength, and so it's getting up.
I think at this point you might be speaking another language, but that's okay.
Yeah, sorry. Effectively, what I'm saying is that it is less harmful than sunlight, and so it is not going to
less harmful than sunlight.
Oh yeah, sunlight's somewhat harmful.
I knew sunlight had a few issues because skin cancer, but less harmful.
Oh yeah. I mean, so UV radiation is somewhat damaging, but again, our skin mainly copes with it. If we didn't nuke the ozone layer, we'd probably be fine here. We wouldn't need to have tons of sunblock. But as a fairly pasty guy, I have to apply a fair amount of it. But yeah, so 5G absolutely is, and also at the levels that they monitor it. So I have got a questionnaire that I'm going to fill out at some point from a 5G concern group, I would politely call them, around 5G policies. And actually, we do make sure the radiation coming out of these towers is low. And again, this is non-ionizing. This is kind of really big wavelength things, so it doesn't do bad things. So like radio waves are huge, right? And so they can go around buildings. We then have kind of Wi-Fi waves, which are a little bit smaller, which, again, very useful for carrying information and technology. Then we have visible light, which obviously we're bombarded with all the time, and that's nice and small there and helps us see. And then we get really small. We get like X-rays, or again, they're the same kind of thing, but they're nice and really small, and use those to see into your body because they can penetrate through things. And you get really, really, really small, which you gamma rays, and the smaller you get, generally, the more harmful. And we're talking about bigger than visible light. So you receive way more radiation by going sunbathing than you do for using Wi-Fi. And that's the justification I've always used for playing computer games instead of going outside. So, but no, in terms of 5G and coronavirus, just look at the countries that have 5G, look at the countries that have coronavirus, and try and draw any kind of correlation, and it will fall apart. There are heaps of countries with 5G that have very poor coronavirus. Take New Zealand, for example. We have some 5G, but we don't have any coronavirus. I think we've got 5G. But there are countries that have no 5G and an absolute ton of COVID-19. And so I think that's the most obvious case to disprove a point there.
Okay. So countries, just to repeat that, so countries with no 5G do have COVID-19?
Yes.
Okay. Right. I think we could leave that one there. I don't even get that picture, Kane. We can share it with the world, but I genuinely don't understand it. So maybe feel free to put it up. Okay, everyone.
Okay. So,
what?
So is 5G a conspiracy to change the batteries in pigeons? I
didn't even know there were batteries in pigeons. So there you go.
I got in trouble for posting a picture to Twitter of pigeon. In Dunedin, we have these pigeons. I think they're friendly. A friend of mine thinks they're very aggressive. But you can go and get some food from the information store, and you should. Don't bring your own. Don't bring food. We have special food for them, so they're healthy, and it's mostly for the ducks. So the pigeons are delightful, and they will come and they'll land on you, and they'll eat your food that you give them, and they're really kind. But no, again, because pigeons exist before 5G, so again, kind of it falls down. Why
would there be batteries in a pigeon? Like, it just doesn't make sense.
No, a lot of these things don't. But again, I think if we want to seriously engage with someone who had a seriously held belief, again, it starts with relationship, right? It starts with going, well, why do you have this view? Why do you have this? Where does it come from? Because it's not like it's a very sensible thing to agree with out of the blue, but probably they've had negative experiences with government agencies or with something like that. So there's a low level of trust in those sources. And so really it's about building up trust there and showing people that actually here is the data that we have, and being less forceful, but absolutely just having that conversation and being able to talk with people. Cool. All right. Was there 2 more questions there? I mean, I can keep going. You've got me rolling.
Okay, one long one. Okay, Ben, are you ready? I can't see it, Kane, sorry.
I can't see it either. My screen's blocked.
No, I cannot.
previous screen's all
You
blocked.
have a black box over it. Sorry, everybody. Please bear with us for a moment. Light tech issue. I don't know where that's at. It's just a bit black. Okay, so Ben, while we can't, well, I don't know if anyone can even see us. Very long question. So, the study of hydroxychloroquine, I can't even say it properly, was stopped by the World Health Organization due to the publication of a paper by the British magazine The Lancet. Later, The Lancet retracted its paper publication since the data used in this study, well, this is a long question, was provided by a company based in Chicago, which didn't want to release the source of the data. It couldn't be peer-reviewed, so it couldn't be verified. After the paper was retracted, the World Health Organization did not resume its studies. Why did it not?
Fantastic question. This is the study that I referenced earlier in the live, where I talked about how there was a study that came out that showed that there was an association between hydroxychloroquine and heart issues. It was widely taken up around in the scientific community because it's what we expected. We had already had some evidence that high levels of hydroxychloroquine can have side effects that include heart attacks and make issues worse. And so then when a very large study came out showing exactly what we expected, that it was not effective at treating SARS-CoV-2, which is what we expected because of various reasons, which we don't need to go into, otherwise we'll be here for all night. But it was the result that the scientific community expected. Fortunately, the scientific community was willing to dig into it, and the Chicago company that didn't release its data sources, also it wasn't aligning with the case numbers that we knew from the World Health Organization and from the hospital data that we actually could access. And so there was this mismatch that got picked up very quickly, which caused a retraction, and the company being unwilling to share its data makes it seem like it was potentially inflating its numbers to make it seem more impressive than it was. It doesn't necessarily mean it is not true, but it does mean that absolutely that paper should be retracted until we can.
So it was pretty dubious, the findings.
Very dubious, yeah. So it was the findings that we hoped, or not we hoped, there was the findings that we expected to see in the scientific community, but the data that backed it up was very dubious, and so it got pulled, and I'm really pleased. The World Health Organization then, I would say, had a bit of a knee-jerk reaction to when that first got published, because there was already a lot of pushback against it because people like Donald Trump had been trumpeting it, and we didn't actually, most people were like, this is not actually a great idea. There's also issues around when you have someone like Donald Trump saying, hey, this is the thing that will cure you. Everybody wants to sign up to those trials, but they don't want to sign up to the other ones. And so you actually have the negative effect of pulling patients away from other trials that might have been more beneficial. So why the WHO then pulled their studies after that one paper, and then didn't reinstate them, I would say probably they pulled their studies because there is other evidence around that it's not working that well. So it's more than just one study, although that one was definitely the biggest and had the largest cohort and the most statistical power. I was a bit surprised that they had that knee-jerk reaction as well. But again, the playing field is moving very fast, and we are having other drugs are coming to the front which are showing an effect that seem to be helping people more. Remdesivir, I'm terrible at saying it, but it's an antiviral that seems to be fairly effective, is being rolled out a bit more. So I think the why is because there are other candidates that have shown a lot more promise, that there is more reason for it to work. So hydroxychloroquine doesn't have a good mechanism of action in terms of actually being effective in the cell. And that's been known, it's been tried, it's been rolled out for virtually every virus, and it never actually comes to fruition. So it wasn't surprising when it doesn't. So I think it's more the surrounding evidence was very thin. The reason it got included in the first place was some really sketchy publications, and so then getting it pulled over a sketchy publication is almost fitting in the end there. So if there was better data surrounding it, I think it would have still been in trials. but the lack of good data surrounding it means that it effectively got into the WHO fraudulently and is now out of the WHO for much of the same reason.
Okay, good to know. Again, that's the science community working to hold each other to account, right?
Yeah, and apologies for the long ramble.
Yeah, it's good. That's a good question. Okay, and the last one is hopefully a little simpler, and I'm really glad this question was asked because I actually wanted to ask you as well, Ben. So, question is, how significant is it that the latest genome sequencing isn't matching anyone from quarantine or from earlier in New Zealand?
Cool. So I'll tackle the second half there first, where the lack of a match from anyone earlier in New Zealand is actually pretty significant and quite reassuring. Because, like the Prime Minister said today, that really does reduce the chance that we've had this low-level, silent transmission going about New Zealand, right? Because where it has popped up now, it doesn't match any of our previous cases. So that's quite reassuring. We can go, actually, we were kind of COVID-free for 100 days. Woohoo! So that's nice. And it does help us reassure us that elimination is still achievable and it's still possible. The not matching anyone from quarantine is interesting. I wouldn't read too much into that at the moment because I don't have complete data on how many people in quarantine get genome sequencing versus just COVID testing. If we had 100% sequencing of all of our cases in quarantine, then that would be even more interesting because then you can effectively rule out any of the breaches. But as far as I'm aware, I don't know if we've got that level of data, whether we can see of all of the people who have breached quarantine and matching their genome cases to the new outbreak. That doesn't seem possible. So
okay, so the fact that they haven't found a link doesn't mean the link doesn't exist, just that they haven't found it.
Yeah.
Okay.
And again, that'll be up to the ministry in terms of how much data they actually release publicly, and I'm not to that data. Nor should politicians out of Parliament be privy to extra data like that and then hold on to it for political gain.
And then just release it to the media. How about that?
Yeah. How
Your
about
opponent.
that? Anyway, small dig. But really what it means is that we've got a bit more work to do. It is good that we can do that tracing, and doing that genome sequencing will also likely reveal the source. There is the idea that it's come in on some frozen food or some frozen packaging. Again, a possibility. Globally, I don't think there has been a positive case that has then been tracked back to frozen food. There has been some detection of virus on frozen food, though. So it's really low as a mechanism because, yes, viruses survive better in the cold than in the warm, but it's a really, really low chance that it's come through that route, and the government is working hard to test that and to eliminate that. And it is one of the times you actually go, yeah, this government has done some good things, and the way they're approaching this track down is actually quite good. Absolutely legitimate to criticize other areas of the lack of testing leading up till now and all that jazz, but this is one area which I think they're doing well in investigating that. So I don't think it's hugely significant yet. Give it a week or two, we'll see where we're at. Genome sequencing takes much more time than PCR, so it's an overnight kind of a deal to get all the preparation done and then actually get the data. And once you've got the data, it takes a lot more time to process it. PCR is really easy to interpret. It's either there or it's not. Whereas when you're doing genome data, you've got to do a lot of other things, like putting all the pieces together and solving that jigsaw. So it's a bigger process, and I would give it some more time before we make any big conclusions about that.
So we still don't know where it started, but hopefully we will find it out. But it's possible that we just will never know, right?
Absolutely. And like we've learnt today that and internationally that's the case. Occasionally you just don't know where it's come from. You just can't track it. You might have had one or two too many people in the line, and you couldn't find them all, and you couldn't test them while they still had the virus. And I don't think we're doing antibody testing in New Zealand yet. Maybe someone can call me out on that one. Right. So testing people well after the fact to see if they've encountered a virus, and also antibody testing doesn't give you specificity as to what the virus was that was in your body, so it's not as good for tracking direct lineages of the virus like genome tracing is. So we may just never know. Some questions can't be answered. What is really important is that we recognize that, like, the virus is the issue here, not the people, and that we continue to pull together to do our best to eliminate the virus.
Awesome. It's a great way to end. And thank you so much, Ben. I am sure people watching would have found that really helpful, as I did. And you've given me a few little things that I can respond to conspiracy theorists with.
Awesome.
So that is very helpful. I'm sure we'll probably do another one of these in the coming weeks as people have more questions. Because apparently there's a lot more questions that we didn't get to. So I'm really sorry if we ran out of time. Everybody, but I've seen it's been nearly an hour 15, and Ben and I will, well, not really me because I'm not a scientist, but Ben can jump into the chat and answer any of your questions directly over the weekend and over next week as well. So thank you so much for tuning in and listening to science. It's technical stuff, but obviously really important, and just stay safe and look after each other. Talk to you soon.
Cool. Thank you so much.
Thanks, Ben.